Okay, well, welcome again to our classroom, and today we will see another problem, but it's like kind of a continuation from what we did on the previous video. But today we will see how to find the length of an arc, area of a sector, to find the length of a segment, the area of a triangle, yes, and stuff like that. So we have the problem here. It says the diagram. So we have the problem here. It says the diagram shows a circle with center O and radius R, which is 8, and the angle AOB, which is given by theta, equals to 1.3. So this implies that 1.3, that one is radian. So part A of the question, it asks you to find the length of an arc AB. So the determination time means for we to determine the length of an arc, area of a sector, area of a chord or triangle, and stuff like that from a given problem, it depends to the value of angle theta. If the value of angle theta is given in degrees, it means we will use the different formula, and if the value of angle theta is given in radian, also a different formula is used. So our theta is 1.3. This one is radian. So since our value of theta given in radian, it means the length of an arc L, this is part A, will be given by R theta. If the value of theta was given in degrees, so the length of an arc, we are saying theta over 360, this we multiply by 2 pi r. This formula is when the angle theta is given in degrees. So since it's given in radian, so here the life is easy. So here for A, the length of an arc R is 8 times theta is 1.3. So simply here we take our calculator, then we say 8 times 1.3, and we find that the answer is 10.4. So since we don't have exactly the unit measurement of R, whether it is in centimeter or it is in meter, so here we can write just units. So that is part A. Part B of the question, it is find the area of a sector OACB or ACB. Simple. The area of a sector, this is given by a half R square theta, and this formula we use because our theta is in radian. Suppose our theta maybe was in degree, so the formula change. This will be theta over 360, we multiply by pi r square. So a half times r, which is radius, r square, so will be 8 square, times theta, which is 1.3. So we plug this in our calculator, 8 squared times 1.3 times that half, and finally we are getting 41.6. And since this is area and we don't have exactly measurements that given, so this we will say it's units square or square units, whatever. So that is the area of the sector. Part C of the question is say find the length of the chord AB. So here you see we have a chord AB. What is a chord? A chord is a line that connects two points of the circle. That is a chord. So this AB is one, this line is a chord. Let me use red color so as you can see it. So this line AB, this is what understood as a chord. Also, in connection to that, also a diameter is a chord, but it is a special chord because it connects two points of the circle, but it passes through the center. So let's see the length of a chord. So if we consider this triangle, this is radius, this is radius, this is O, this is A, and this is B. So we have here is 8 and here is 8, and the angle O we have, it's 1.3. So how can we get AB? So here we can apply cosine rule. So the cosine rule, it says what? It says A squared equals to B squared, U plus C squared, U minus 2BC, then multiply by cosine of angle A. Simple. So our A square, this will be the length AB square. Our B square and C square are this one, 80 square plus 80 square minus 2B, which is 8 times C times 8, then cosine of angle A. Cosine of angle A, it is cos of 1.3. But here, once we plug in our calculator, we need to be careful. Our angle given, it is in radian, so our calculator should be in radian mode. So make sure that you put your calculator in radian mode while plugging the question. So, okay, I'm plugging now. So that much multiply by that 8 times 8 times 2, then we'll get 8 square, which is 64 times 2 minus answer. And finally, if you plug the whole thing in the calculator, you will have to get 93.76 and 0.15. You are advised, make sure that your final answer is the one which should be in 3 significant figures. But all other answers which you are getting in between of your calculation all the way to your answer, at least should be to 4 decimal places. At least it is advised so, because the more you approximate early is the more you might diverge to the accuracy. So the final answer should be the one which approximated to 3 significant figures, but all other calculations in between, it is advised to be at least to some 4 decimal places. So then I square root that answer, square root both sides, and finally I'm getting AB, which is the length of the chord. It is 9.68. This is units. Then part D, it says find the area of a triangle. Part D, we are finding the area of a triangle. So the area of a triangle, we know, is given by area equals to a half AB, you multiply by sine of angle C. So this is 8, this is 8, this is 1.3, so it is a half. Our A is 8, our B is 8, our sine of angle C is 1.3. Very simple. Then we plug in our calculator so as to see what are we getting? Then multiply by that much, multiply by that much. You will find that the area of a triangle, it is 30.833861, which is equivalent by saying 30.8. This is units square or square units, whatever you might call it. Part D of the question, let me write it here. Delete this. I'm deleting this, delete this. So as I can at least write it here. Delete that, delete that, delete that. Okay. So part D of the question, it says find the area of the shaded segment. So the area of the shaded segment, if you observe it properly, you will find that it is equivalent by taking area of the shaded. This is equivalent by taking area of a sector, the whole sector, u minus area of a triangle. Area of the whole sector, we do have, what is it? It is 41.6 minus the area of the rectangle, we do have, it is 30.8. So 41.6 minus that, you will be getting 10.76, which is equivalent to 10.8 units square. So what's important here is to understand which appropriate formula you need to use at which situation. So you need to take into account whenever given the angle theta in terms of degree, you need to use the appropriate formula. And whenever given angle theta in terms of radian, you need also to use the appropriate formula. So otherwise, this is how you are supposed to attempt the question that are related with arcs and sectors. Thank you very much. See you on the next video and happy learning.